Hi, I'm Nigel Griffiths. I work in the Advanced Technology Group, part of IBM Europe. In this Power Basics movie, we're going to be looking at the new Virtual I/O Server 2.1. The features in there, hopefully to get you off to a flying start. I'm going to do a quick recap of the previous versions. There's some features in there that I know a lot of customers aren't using, and then we'll look at some of the details of 2.1. This is the feature list that was in the announcement for VIOS Server 1.4. A couple of things I'd like to highlight there. The system planning tool is improving with each version of the VIOS server. This is a standalone tool where you can design all your logical partitions and your virtual resources before you actually get the machine. And once it's available, you can then use the system planning tool to implement your configuration automatically on the machine. I know a lot of my service colleagues use this to great effect to get the machines up and running very quickly. 1.4 also came out with the time frame of the Power 6 first machine, and so we supported the hardware involved there. One feature that a lot of people don't realize that they have with 1.4 and onwards is this GVRP. With standalone Ethernet switches using VLANs, the switches communicate using this protocol so that they can understand that part of the VLAN is on this switch and a part of the VLAN is on the other switch, and so they need to transfer packets between them. Of course, inside the Power machines, we have an Ethernet switch implemented in the firmware of the machine as the hypervisor. And the hypervisor can use this protocol to communicate with physical Ethernet switches so that they understand that inside the machine is part of a VLAN and packets have to be sent and taken from the software switch inside the machine. With 1.5, we had some extra Power 6 machines, so they're supported. One of the big items was partition mobility with the Power 6 machines only. 1.5 of the VRS, of course, runs on the older machines as well. We also have some features that I particularly like is the file-backed virtual SCSI devices. We'll have a look at that on the next file. And then we have the virtual optical library that I seem to use every day. Again, features that people don't really realize are actually there. Also, the IVM mode of working, that's machines that are using the virtual I/O server without a HMC, because the HMC function is actually running on the VIO server itself. The IVM caught up with some of the features in the HMC. Now, with the file-backed virtual devices, we've already had for a long time various virtual SCSI devices, disks, that we could give to the logical partitions. We can give a whole disk, as the VIO server can see it, to the client. We could create a logical volume on a disk, and the logical volume can be given to the client, LPAR. Or we could get a LUN. It looks like a H disk, but it's actually a LUN implemented in the disk subsystem. It could be spread across lots of disks, of course, inside the LUN, but that again can be given to the logical partition. With the file-backed way of doing this, we have a storage pool which maps to a volume group in AIX, and inside that storage pool then you create a file-backed storage pool, and that is actually a JFS file system sitting in a logical volume. Once you understand that the file-backed storage pool is actually inside a storage pool, then you can rapidly understand what's going on, and then you can create large files. So if you want to give an 8 GB virtual disk to a client, you create an 8 GB file in this file system. Now, some people ask me why we're doing that. Well, I think it was fairly simple to implement. Some people like the idea that they're large files and that makes them easier to back up than the logical volume. And it's actually pretty fast. The developers were surprised how fast it is. I guess that's because the journal file system is very lean and mean and doesn't take a lot of CPU resources to run anyway. So it was pretty quick. So we enjoyed the benefits of being able to back these up much more easily. On the virtual optical library, again we create some space on the virtual I/O server, maybe 32 gigabytes of space, and we create that into a repository. It's a file system, and inside that file system we can then put ISO images as they would be on a CD or these days a DVD. We can then mount those or load those images into a virtual optical device, and that's shared via the virtual SCSI device drivers between the VIOS server and the client. And then the clients can do a config manager, and they can now find a new DVD device and mount that and access the ISA image on the VIOS server. That can be a pretty effective way of perhaps implementing new software on your clients, or in fact you can boot. If the DVD is a copy of the AIX boot and install DVD, then we can actually install multiple logical partitions at the same time via the VIOS server and the optical library. I use this all the time as I get beta versions of new code. I can actually quickly boot up a new copy of AIX, for example. We can also have a read-write device. In this case, we pre-create an empty file of a certain size, and then when we connect it to a logical partition, this behaves like a writable DVD drive, and we can actually do a backup into that. This is particularly nice because we can then back up our logical partition, and we end up with a file on the VIOS server, and we can back it up from there. With release 1.5.2, it was a fairly small release, one of the minor releases in June 2008. We support some new hardware, the large top-end machines. We also starting to support IBM I. You can see on this list we have some other things. We have the IP version 6 is starting to be implemented for the VIOS server. That's important for some large government contracts. We have some SIM, the Common Information Model, which helps tools like the IBM Director 6 that's just come out and will support the VIOS server. We have some shared Ethernet adapter quality of services features, so we can decide which packets are more important as they're going over the VIOS server. We also have a way of copying virtual disks with this new command, but do note the actual command was renamed, and you need to look in the manual pages for the cpvdi command. And yet more updates for the system planning tool, and it's really been renamed the system planning and deployment tool, though everybody still seems to refer to it as SPT. Okay, let's move on to the Virtual I/O Server 2.1 that came out in November 2008. This is a list of features that I thought were interesting in the announcements, and we'll look at some of these in detail. Feature 4 there we'll just mention. We have partition mobility. In the past we could only move a logical partition if the two machines were connected to the same HMC. Now we can do it between HMCs and between machines that are perhaps further apart. Further support for IBM I. And feature 7 we have an update to the PowerVM LX86. This is a tool that translates Intel Linux binaries, and we can run them on Linux on Power. We'll look at the other 4 features in detail in the coming files. First, there's a statement of direction. There's an intention by IBM to do something with the active memory sharing. We'll look at that briefly later on. With N Port Id Virtualisation, it's not available currently on the Power 595, although it will be when the new I/O drawers that support PCIe adapters are available. We are going to support that also on the JS 12 and 22, the blades, the Power 6 blades, and we need another adapter to go into the Blade Center to support that. And sometime in 2009 we'll also support NPIV with IBM I and Linux environments. They'll need new versions to come out for Linux, and I believe the IBM I will need a PTF. We're also going to support the virtual tape capabilities with Linux and IBM I in 2009. Of course, all statements of directions are subject to change. Now, the upgrade process to get to VIOS Server 2.1 is more complicated than previous updates. That's because we're changing from it being AX5 based to AX6 based. So to take that update, you need to use the migration DVD. So there's a big warning there that it's not the regular install DVD. You need to migrate DVD, and that is downloadable from the IBM website for where you get regular updates. Now, because it's a change of AIX version, you'll do a similar process as you would do for upgrading AIX, and that will take roughly an hour or so. You can do that from NIM if that's your preferred option, and it will preserve all the VIOS server configuration and resources. Once you've gone through this migration process, you'll be back to the regular VIOS server fix packs to take further improvements. Now, for dual VIOS servers, you can do this online in a non-disruptive way. So you can update one VIOS server while the other one does all the I/O, and then you can do a fall over to the updated one and then update the second one. Now, of course, you'll be running in a mode there with 1.5 on one VIOS server and 2.1 on the other. Now, this will actually work fine. We don't recommend you stay in that state. You might be tempted to use some new features that are available on the 2.1 that will not be available on the older copy of the VIOS server. So I think it would be sensible to upgrade both VIOS servers perhaps the same day or perhaps over a weekend, for example, once you're confident that it's going to be okay. Up until now, the VirtualIO server has provided storage virtualization so that the VirtualIO client logical partition just sees a generic SCSI disk and so uses a device driver to communicate with it. The VIOS server hides from the client what the disk actually is. It could be a SCSI or a SAS internal disk, it could be a SCSI external disk, or it could be a SAN disk coming in from external SAN subsystems over fiber channel. These, if you like, land on the VirtualIO server, and the VirtualIO server hides what they actually are from the clients. This is called the storage virtualizer mode of working. And it means that the disks, if you like, land at the VirtualIO server, and the VirtualIO server understands them and passes them on. But it also means that the VirtualIO server is the target for these SAN disks. Our SAN administrators have to give the disks via their zones to the VIOS server, and they are not really sure what the VIOS server gives them to. This can worry some of the SAN administrators because they often have perhaps high-speed brand new disks that they want to use for new important production workloads, and they may have an older generation of slightly slower disks that they'd like to use for internal purposes, perhaps development and test and internal systems. But because they have to give them to the VirtualIO server, they can't be sure of where they're actually being used inside the power machine. All of that is going to change with NPIV. Here, the VirtualIO server is going to work in what's called a pass-through mode. So the packets of information will come over the SAN in through the adapters connected to the VIOS server, and the VIOS server will just pass the data back and forth to the client. It will not take any other interest in what's actually the contents of those I/O transfers. This means that the VirtualIO client is now the target for the SAN-based LUN, and it will have a better understanding of where this data is coming from and the sort of device that it's talking to. Now, to get NPIV running, what do we actually need? Well, if you start at the bottom, we don't actually need NPIV support in the disk subsystems. So that can be good news if you've got older subsystems that don't support that. Then we have what's called the entry SAN switch. This is the switch that our Power 5 and 6 adapters are actually connected to. This switch has to be NPIV capable. Now, I'm told by my storage colleagues that this may be what's called an advanced feature, and you may have to actually purchase NPIV capability on your switches, so that's worth checking. Across your SAN fabric you can run at 2, 4 or 8 gigabit, but I'm told that it's not supported over 1 gigabit SAN fabrics. Now, in the Power 6 only machines for NPIV, we use this new adapter, so PCIe 8 gigabit adapter, a fiber channel adapter, and it can run at 8 gigabits of course, but it can also fall back to 2 gigabit or 4 gigabit mode if that's what your fabric is running at. You'll need the VirtualIO Server 2.1, you can't use older versions. You'll also have to update your firmware. It has to be the EL340 firmware, and I'm afraid if you're on older versions of the firmware, that is a disruptive installation of the new firmware. You'll then need to connect the VIO server to the VIO client with virtual fiber channel adapters. We'll look at that on the next file. Then in your VIO client, it will be connecting, rather than a generic SCSI device, it will actually understand that this is a fiber channel device because it'll have a fiber channel adapter, and it'll actually be able to understand what sort of device it's talking to at the far end. The VIO client needs to be these levels of AIX. They're the versions that came out in November 2008, and these are the versions that we're told will run with Linux on power as well. Also, on top of that, we'll need the new HMC that came out in November 2008. That's 7.3.4. So to implement this is quite a lot of new software and firmware and HMC levels. So if you're doing a brand new machine install, that's okay. You'll just get the latest versions of everything and off you go. If you're doing an update to try and use NPIV, then you'll see there's quite a lot of work updating your machine in terms of new adapters, new VIO server, new firmware, new copy of AIX, and a HMC. So how do we actually connect these things up? Well, on the HMC, when we create a logical partition, instead of creating a pair of virtual SCSI adapters, now we create a pair of virtual fiber channel adapters. Like in the SCSI case, we have to connect the fiber channel adapter on the client to the server and vice versa. Once we've actually created this pair of virtual fiber channel adapters, if we go back in and edit them, we can see that we get two worldwide port names as listed here, and we actually use one of those port names for this particular time, and the second one is used when we do partition mobility. The target machine will actually use the second worldwide port name and actually connect to the same LUN, and then when we've actually done the move, the first one becomes available for the next move we want to make. Once we've made that pair of fiber channel adapters and connected them together, we have to connect the server fiber channel adapter to the physical real adapter in the VIO server. And to do that, we use this VFC map command. We can see a worked example here. There's two commands that can help us out here. The ls map command will actually tell us what's connected to what, and the ls nports command will actually give us a list of our NPIV ports so we can see what we can connect to what. Of course, outside the machine, the SAN people also have to make changes to the zone, because now they'll have to map a particular worldwide port name straight through to the client's logical partition. The data will be transparently relayed by the VirtualIO server, but otherwise unaffected. Here are some details of the fiber channel adapter. This is the only adapter that we're supporting NPIV in initially, and we can see some details about the connectors, for example. I just put that in for extra information, and we can even see the part number there that you need to order. One side effect we have is that if you want to use a fiber channel tape drive, then you'll now be able to do that. Typically these will operate by the back-end client software talking over the network to the tape library to get the right tape installed into the server. And then we want to do a fiber channel backup, and because we're NPIV and the client understands directly what it's talking to, we can now do a SAN-based backup at high speed to the tape drives. Previously, with our virtual SCSI, it looked like this. In this case we have the dual VIO servers. The AIX client in the middle here is using AIX NPIO to share the load between the two virtual SCSI adapters. When it arrives in the VirtualIO server, it goes through multiple levels into the logical volume manager, perhaps into multipathing, so that we can use more than one adapter in the VIOS server to write the data out into the SAN. Now this changes a little bit when we go to the NPIV way of working. Here now you'll notice that what happens in the VIOS server is very simple. As we have a pass-through mode, we simply pass the data packets back and forth, and it's a one-to-one mode. The virtual fiber channel just puts all the packets into one fiber channel adapter. So we no longer have multipathing in the VIOS server. And that is now performed on the client. So the client knows about the storage multipathing in here. So if we're using different fiber channel disks, subsystems from different vendors, we'll use their multipathing software here. Then we'll actually talk to the different HBAs over the virtual fiber channel adapters out onto the real world. This means that though for every client it's a more complicated setup, because we'll have to install the storage multipathing in each client, where in the past we've only had to do that in the virtual I/O server. Because it's a thinner stack on the virtual I/O server, there might be a slight performance benefit in here. It is going to be small because the overhead wasn't very large in the first place. I know a lot of customers are very interested in NPIV. This makes available all of the features and functions of your SAN disk subsystem again, without the VIOS server getting in the way. There is the downside, of course, that you need those prerequisites, and it does make your virtual I/O clients more complicated because each one of them will need to be set up to do multipathing. If we now move on to virtual tape drives, a little bit like the virtual optical library that we had, we now have the same sort of features with the virtual tape. The virtual tape drive is connected via the virtual SCSI, like we did with the virtual optical devices, and then the client logical partitions will just be able to find a tape drive connected to their virtual SCSI, and then they can do reading and writing back up in particular to their virtual tape drive. Of course, the tape drive can't be shared between two logical partitions. It was supported on AX5 and AX6, and these are the actual part numbers of the internal SAS tape drives that we're supporting. The next subject is heterogeneous multipathing. This is where we have a real regular fiber channel adapter in a client logical partition and the virtual NPIV fiber channel adapter in the client partition that runs through the VIO server and out into the real world. So we could have, as an example, one real adapter and one virtual adapter in the client. Two immediate uses for heterogeneous multipathing. First is to reduce the number of adapters, particularly for small logical partitions that aren't going to push their adapters very hard. We tend to put in one adapter to do our I/O, but a second adapter for redundancy in case we have a failure with the adapter or the cables or the switches further out. So instead of having two physical adapters, we now move over to have one physical adapter, and in failover mode we'll have the second adapter as a virtual adapter. This reduces our costs in the number of adapters, and it also frees up I/O slots. Another reason for having it is that in partition mobility, we can only do partition mobility with virtual adapters inside the logical partition. But if we really need to have dedicated I/O adapters, then we can't do partition mobility. But we could add two virtual adapters to our logical partition. We could move the I/O to the virtual adapters and then remove the physical adapters. Then we're in a position to use partition mobility to move the logical partition between one machine and the other. Then we can add the physical adapters back and move the I/O back to the physical adapters. So that allows us to effectively do partition mobility but still be using dedicated adapters. That's a really nice trick. Now that is fairly complicated, and I would recommend that people practice that before they actually want to do that in real life. Now a few words on active memory sharing. This is a statement of direction, so it's not available right now. It's actually in beta tests already and will be available in 2009. We already have shared CPUs, in our shared processor logical partitions, where we can move the CPU cycles from one logical partition to another very rapidly, in microsecond sort of level. The idea is to have a similar sort of technique for memory, where we can move a few megabytes or even a few pages from one logical partition to the next. But of course we can't move memory pages unless they're actually freed, so that might actually require disk I/O to page out the contents, so they're not going to move as quickly as CPU cycles. But this allows us to free up some of the memory pages that are really unused in a logical partition and give the pages to a logical partition that really could do with more memory to stop it doing so much paging. It also allows us to reduce perhaps the size of a configuration of a machine. We might add up all the logical partitions on a machine that we're trying to configure, and that may turn out to be a certain size, and that may force us to use the larger memory DIMMs, which come at a price, of course. If we can get the logical partitions to share some of this memory, be somewhat more flexible, we could actually reduce the memory requirements, and that may actually let us buy the smaller memory DIMMs and actually save quite a lot of money. It also allows us to start up what would otherwise, if we used dedicated memory, which we had for a long time now, it allows us to start up a set of logical partitions that would be impossible using dedicated memory. So we may be able to start up a system test logical partition to allow somebody to extract some files from it, for example, where we couldn't have actually started it in the past. It also allows us to find the memory that's not actually used. That can be actually quite difficult to do on a production machine. We know that AIX tends to use all the memory it gives it because it's trying to reduce the I/O that it's going to do. Now there are some prerequisites for this when it becomes available. All the latest HMC firmware VIOS server and AIX 6. This won't be available with AIX 5. And of course there may be newer versions by the time active memory sharing becomes available, so it will be those versions that will be required. A couple of extra things has been added to the virtual I/O server. Because it's based on AIX 6, we actually have the nmon layout as a performance monitoring tool inside Topaz. Now if you start the Topaz command, you can actually then hit the tilde character and flip into nmon mode if that's what you want to do. There's also been improvements to the VIOStat command. That's the virtual I/O server version of the IOStat command, and the fiber channel stat command. Go and have a look at the menu pages to find out some of those extra features in there. And ENTstat, CStat and NetStat have got some extra information in there as well. As an example, in the Topaz mode of operating, there's some extra details in here when you're looking across all your logical partitions in your machine from your VIO server. So at the top there we can see all the logical partitions running on the machine and what they're doing. We can see in the middle, if you hit the E, you can see the virtual Ethernet adapter running, the C, and which of the clients is actually doing the I/O, which can be very useful information to find out who's actually keeping your virtual network busy. If you hit the capital D again in this KEK display, then you can actually see for the disks who's keeping the virtual disks busy on your virtual I/O server. Very important information if you're trying to manage your virtual I/O server and trying to work out who is doing what. Already mentioned the system planning tool. This continues to improve, again with the VIOS server 2.1. A load of features here, supports adapters that aren't actually allocated to a partition, perhaps they're a spare pool of adapters. We can have expansion units included in the plan. We can have an estimate of the power consumption for the Power 6 based machines. We can use the workload estimator output and put this into our system plan to pre-specify some of the logical partitions. And we've got more better installation of the plan once you've generated it. Well, I hope you've enjoyed our movie here to take you through some of the key features with the Virtual I/O Server 2.1.